Hello, hopefully you're doing well and you are surviving the snow that we're having today. I can look out the windows and see it's still snowing and we got some snow on the ground. Um, Today, what I want to do is I want to give you a little bit of a video and then a few questions about diodes and why diodes are important, how diodes work, and just like where we use them. Um, So I want to start off with the idea. The first thing, let me give you a couple of examples of where we use diodes. Um, One place we use diodes is in our computers, our laptops. I have a Chromebook right here, and we use diodes to power them. I've got a power supply right here. And why do we use diodes to power them? All of those computers use direct current. Okay. So they, just like the way a battery works and only sends current one way. Remember, there are AC, sorry, and DC. I've got some things coming to make my writing much better on this. So AC, the current goes forwards and backwards, right? Remember, it goes back and forth, back and forth, back and forth. DC, it only goes in one direction. So computers run on what? DC current. Okay. But when we plug them into the wall, we plug them into AC current. So, how do we turn AC current into DC current? That's the question. And it's actually rather simple. Basically, what you need to have is something that will only let, remember, AC moves back and forth, back and forth, back and forth. What if I had a valve there that when everything moved this way, it opened up, and when it tried to move back, it closed. So it would only let things through one way. That is essentially what a diode does. So you can take AC current, turn it into DC current. The other major place that we use diodes is LEDs, which I have an LED light. I don't want to blind you with it here. Let me turn it off for a second. I have this LED light right here that I use at my desk. And LEDs are nothing more than what I'm going to describe to you, but when they are in operation, they give off light. Okay. So when they're working, they give off light. That's the strange thing about LEDs that we've actually been able to use to our advantage. So what does an LED do? In order, or what does an LED or a diode do? Remember when we were doing our light experiment and we used the LEDs, you had to put the LEDs in a certain way because one way the LED would allow light to, or would allow electricity or electrons to flow, but when you turn it around, it would not let that flow. That's exactly what a diode does. It's a one-way valve for electricity. Here's how it works. In a diode, you end up with, I am a genius drawer here. You end up with two, I'm an artist, I guess, two sides, two parts to it. Both of these have a base, which is silicone or silicon, and both sides have an impurity added to them. We're going to call this side the N side, which is what they use. There's an N side and a P side on diodes. The N side will also show you, I tend to call that negative and this positive. That's what the N and the P come from. The N side has lots of electrons floating around in here. They're extra electrons that are just floating and want somewhere to go. Okay. The P side has holes where an electron should be or could be, but is not there. So it has holes all over in it. So I'm going to draw some of these, but there are literally millions of them in here because it's at the atomic level. Okay. All these holes over here. So you have sort of a negative side and you have sort of a positive side here. Now, on the negative side, in order to get an extra electron, if you think about this, we're going to use something. Let me go over here to periodic table. We're going to use something from the group 15. Okay. Why do we use group 15? Group 15 has 5 valence electrons. Okay. So let's go back to our drawing and just take a look here. If we have, basically it's a lattice structure. We have silicon, 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 silicon. And we can go back and say how many valence electrons does silicon have? And you'll find that silicon has 4 valence electrons right here. It's number 14. So silicon doesn't have any extra electrons and is very stable, wants to be exactly where it is, because what silicon will do is they will share electrons in the lattice format and everybody will have 8 valence electrons, right? If there's silicon atoms all around it, they will be sharing all around it. Be another silicon atom at the end of each of these. But in the center here, we're going to throw our impurity. So our impurity, let's say we use antimony, SB, okay? So we go back here and we go, let's throw an SB in here. Okay, so I'm going to change color. So in order to make this work, I've used, why am I, I guess we'll stay that color. Here we go. Okay. I don't know why I can't change the color. Oh. How about we do that? Okay. So I'm using up 1 electron here, 1 electron here, 1 electron here, 1 electron here, because we're sharing. So I've used 4 electrons and I have 8 electrons in my outer shell. So I'm all happy right now, right? And all my silicons are happy right now. But remember, I had 5 valence electrons. So what happened to that extra electron? Well, that extra electron is sitting out here looking for somewhere to go. Okay. On this side, on the other hand, I have silicon, 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 silicon. Basically the same structure I have over here. But let's say in the center of this, I put boron. Okay. So I'm going to put boron in here. And I'm going to have the same structure, but I'm going to make a little small thing here. And I'm going to say I'm using 1 electron here, 1 electron here, 1 electron here. And right here, I only made this like small because I'm missing an electron. So right now, this portion of this mixture only has 7 valence electrons. I got 4 from the surrounding silicon atoms that we're sharing, but I'm missing 1 because I've only got 3 boron electrons. So that's how we get to the point where this one side is positive, one side is negative. There's holes over here for the electrons to go into, and there are electrons over there to go over. So let me erase this, and I want to show you the next thing. Okay, so what happens when you create this system? What happens right away is that down the center, what's going to happen is some of these electrons are going to come over here, because along the line you have the positives and negatives right next to each other, and they attract each other. Okay, they're right next to each other, these holes, and these electrons want to jump into those holes. So right along the line between the two, this will happen. Okay, when that happens, here's what it does. When that happens, I'm going to erase this again. When that happens, it creates a barrier. Let me go here, make it green. It creates a barrier. Let's go here, right along here, because I've kind of cleared out all of the different electrons here, and I've filled up the holes right on this line. So I kind of have a barrier where I've got sort of a positive fence on this side and a negative fence on that side. Okay. So I have this barrier that all of these things over here want to go over here, but there's a barrier in the way. Okay. And that barrier is caused by the very forces that want to push these over to here is what creates that barrier. Okay. Now, what happens is if you apply, let's say we apply a battery to this. I'm using a battery just because it's easy. This could be an AC power supply. It wouldn't matter. If I apply a battery like this, where the electrons are moving like that, okay, so I'm pushing more electrons into here. These electrons, they build up pressure, and then they finally get enough pressure where they're able to jump and go over. Okay. That pressure is equal to 0.7 volts. Almost did that wrong. Let me try this again. 0.7 volts. So 7/10 of a volt is the amount of pressure it takes to push those electrons over that hump and get them over here. So when you put a diode in any line, any circuit, you're going to lose 0.7 volts. So if this battery was at 0.5 volts, like if it was a half a volt battery, nothing would happen. If this was a 2-volt battery, then the end result would be you would have 0.7 volts used up here, and you would get 1.3 volts of usable power from here, because they're using up some of it to make this happen. Okay. Now, what happens if we instead get rid of all these things? What happens if we reverse the battery and go the other way? So I go, put the battery in, hook it up. Electrons are trying to move this way, trying to come that way. I send electrons into here, and what happens is, because the electrons go flying through here, hit this, they like start filling up these holes right here. Okay. And what ends up happening is the barrier gets increased, and it looks like something like this. This barrier will become larger and larger, mainly coming back to the right here because you're filling up the holes. So the barrier gets bigger and bigger, and the more you try to put power through backwards on a diode, the the less likely it is to work. Okay, they're not perfect things. There might be a little flow through or something, but by and large, this is how it works. So that's why you can only go one way through a diode. Now you can use diodes in a couple different ways. I'm going to do this. You can use diodes, like I said, in um, converting AC power into DC power. Um, there's also a way, like if you look at AC power, you have I like to think of it this way because I think it's easier. You have power go this way, then you have power go that way, then you have power go this way. It ends up looking like a sine wave. That was a very bad sine wave. But what the diode can do, if you use 4 diodes, you can end up building something called a rectifier, so that you basically change this format into this. So you don't actually lose this power. You turn this power around and go that way with it. That's what a rectifier does. But it's the same idea, but it it actually saves quite a bit of power instead of just using up and losing that power. So we use diodes in many, 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 many applications. Lots of electronics. Almost everything you do that is electronic has printed circuit boards or any of that small stuff. Most of that stuff uses a very low level of power, like 6 volts, maybe a high of 12 volts, and then it almost all only uses direct current. So you have to have diodes in order to make that happen. There's a lot of other things you can do with diodes that are much more tricky and much more inventive, but this is the really the basic thing that I want you to catch on diodes. So I'll put together a few questions for you, but it should be pretty simple. And I'm thinking I may put a couple of the videos that I've watched in there in case somebody wants to get a little more background on what diodes are and how we use them. So hopefully you have a good day and enjoy your time at home.